So what, see, just see here, we have int main, which is our main function from where the program starts. We have what? We have declared x and initialize it to what? 7.
oh,
Okay. And then what we're doing, but um, we are printing p, no, p should give the address of x, which is minus this and minus this. See, both are same. See, when we have assigned what? Address of x to p.
oh,
Okay, now what I'll do, I'll add here ampersand, that is not ampersand, what will you call it? Value at. Value at p. So what should this statement print now? This should print what? 7. Howda? As per our knowledge, this should print 7.
oh,
So let's run this. See, what it did, it printed 7.
oh,
Also, when you compile each time, every time compile ಮಾಡಿದಾಗ, the address changes
oh,
because it's using random access memory, no? Therefore, each time you compile, the address changes if we
oh,
made any changes to our program. So here what it's doing, we what declared the pointer and we initialized to p to what? Address of x. Therefore, address of x is this number,
oh,
and the value at pointer p, that is value at where pointer p is pointing, is
oh,
7. Okay, now
oh,
let's go to double pointers. Let's search over here only. What are double pointers? Double pointers. Double pointers andre ಏನು? A variable that stores the memory address of another pointer.
oh,
Okay, ಅಂದ್ರೆ double pointer is what? A variable. Now ಇದನ್ನ before double pointer ಇದನ್ನ ನಾವು ಹೆಂಗ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ, instead of this statement, instead of assigning it separately, what we can do is we can assign this over here itself, equals address of x. Now, as per our knowledge, what does this statement say?
it stores the address of 7 is X.
Huh?
ಯಾವ್ದು? 8 star B ದ?
ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಸಿಕ್ಸ್ತ್ ಲೈನ್ ಏನ್ ಹೇಳಕ್ ಟ್ರೈ ಮಾಡ್ತಿದೆ? ಸಿ ಇಲ್ಲಿ ಪಾಯಿಂಟರ್ ಅಟ್ ಪಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಅಡ್ರೆಸ್ ಆಫ್ ಎಕ್ಸ್, ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಅಟ್ ಪಿ ಗೆ ಅಡ್ರೆಸ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಟೋರ್ ಮಾಡು ಅಂತ ಹೇಳಕ್ ಟ್ರೈ ಮಾಡ್ತಿದ್ದೆ, ಬಟ್ ದಟ್ ಈಸ್ ನಾಟ್
ಹ್ಮ್,
ದ ಕೇಸ್. ಸಿ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಸೇಮ್ ಆಸ್ declaring it, and that is int star p and p equals address of x. So this line and this line both are same. ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬಾರ್ದು ನಾವು. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ವ್ಯಾಲ್ಯೂ ಆಟ್ ಪಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಅಡ್ರೆಸ್ ಆಫ್ ಎಕ್ಸ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡಕ್ ಟ್ರೈ ಮಾಡ್ತಿದೀವಿ, ಬಟ್ ದಟ್ ಈಸ್ ನಾಟ್ ದ ಕೇಸ್. ವಾಟ್ ಈಸ್ ರಿಯಲಿ ಹ್ಯಾಪ್ನಿಂಗ್ ಈಸ್ ಬರೀ ಪಿ ಅಲ್ಲಿ ಅಡ್ರೆಸ್ ಆಫ್ ಎಕ್ಸ್ ಹೋಗುತ್ತೆ, ವೆರಾಸ್ ಪಾಯಿಂಟರ್ ಪಿ ಅಲ್ಲಿ ನಮ್ಮ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಕ್ಸ್ ಹೋಗುತ್ತೆ. ಗೊತ್ತಾ? ಲೆಟ್ಸ್ ಟ್ರೈ ಟು ಪ್ರಿಂಟ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ಅದೇ ಸೇಮ್. ಲೆಟ್ಸ್ ರಿಮೂವ್ ದಿಸ್ ಅಂಡ್ ಲೆಟ್ಸ್ ಜಸ್ಟ್ ಪ್ರಿಂಟ್ ವಾಟ್ ದಿಸ್. ಸೊ ಟೆಕ್ನಿಕಲಿ ನಮಗೆ ಏನ್ ಪ್ರಿಂಟ್ ಆಗ್ಬೇಕು, ಮತ್ತೆ ಇಲ್ಲಿ 7 ಪ್ರಿಂಟ್ ಆಗ್ಬೇಕು. ಓಕೆ, ಸೊ ಸಿ ದ್ಯಾಟ್ ಈಸ್ ವಾಟ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್. ಗೊತ್ತಾ? ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದೋಸ್ ಟೂ ಲೈನ್ಸ್ ವಿ ಕುಡ್ ಜಸ್ಟ್ ಅಸೈನ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಅರ್ಥ ಆಯ್ತಾ?
ಹಾ, ಹಾ,
ಸೊ
ಅರ್ಥ ಆಯ್ತು.
ನಾನು ಪಾಯಿಂಟರ್ಸ್ ಯಾಕೆ ಇಷ್ಟು ಸ್ಟ್ರೆಸ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ನಮ್ಮ ನೆಕ್ಸ್ಟ್ ಡೇಟಾ ಟೈಪ್ ಆರ್ ನೆಕ್ಸ್ಟ್ ಡೇಟಾ ಟೈಪ್ ವಿಚ್ ಆರ್ ವಾಟ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್, that are
ಹ್ಮ್,
heavily related to pointers. Therefore,
ಹ್ಮ್,
if we
ಸರಿ.
don't have any idea about pointers, then will face some difficulties in linked list. So
Hmm.
therefore, understanding pointers is very important. Now let's go to double pointers. What are double pointers? A variable that stores the memory address of another pointer. Let's go to images and let's see. So this, let's go here. Oh, it opened YouTube. We don't want. Yeah, let's go somewhere. Yeah, this is our code, I guess. Double pointers.
Hmm.
Explain ಮಾಡ್ಬಿಟ್ಟ ನಾನು but we don't need all that. See, we defined what x ಅನ್ನ declare ಮಾಡಿದ್ವಿ, then we assigned. See, that is what we're doing here. We assigned value at p equals address of x. That is what they did here.
Hmm.
Value of value at p equals address of x. But in reality, what is happening? Value at p is what? 10. See, int x is a variable of type int which is holding what? 10. And the address of x is what? Hexadecimal number. What is this? Hexadecimal number. Okay. Now this address, now this pointer is pointing to this address, the address of x. Okay, address of x ಅನ್ನ point ಮಾಡ್ತಿದೆ. What, which pointer? This value at p is what? 10. And in p what is there? The address of x. So
Hmm.
what does double pointers do then? Value at double p equals address of p. That is
Hmm.
what? Now, if I say what is in pp, you say the value in pp is what? Hexadecimal number, which is the address of pointer p.
Hmm.
Okay. Now
Hmm.
this double pointer is pointing to what? The double pointer is pointing to p, which is again pointing to
Into variable X.
variable x. That is value of x.
Hmm.
Okay. ಅರ್ಥ ಆಯ್ತಾ ಇಲ್ಲಿಗೆ double pointers?
Hmm. Correct.
Okay. Now, what is our general understanding of arrays? ಅರೇಸ್ ಅಂದ್ರೆ ಏನು? ಲೈಕ್ ಲಾಸ್ಟ್ ವಿಡಿಯೋ ಅಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ ಅರೇ ಅನ್ನ ಮ್ಯಾನಿಪುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ವಾಟ್ ಈಸ್ ಅ ಜನರಲ್ ಡೆಫಿನೇಷನ್ ಆಫ್ ಇಟ್? ಅ ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್. ಅರೇ ಇಸ್ ವಾಟ್? ಅರೇ ಇಸ್ ಅ
Data
ಡೇಟಾ
structure.
ಸ್ಟ್ರಕ್ಚರ್ that stores a collection of similar elements. ಈಗ ಇದು ಜಾವಾ ಸ್ಕ್ರಿಪ್ಟ್ ಅಲ್ಲಿ ಡೆಫಿನೇಷನ್ ಒಂದು ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಬಟ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕೇಸಸ್ ದಿಸ್ ಇಸ್ ದ ಡೆಫಿನೇಷನ್. ಕಲೆಕ್ಷನ್ ಆಫ್ ಸಿಮಿಲರ್ ಎಲಿಮೆಂಟ್ಸ್, ಲಿಸ್ಟ್ ಆರ್ ನಂಬರ್, ಲಿಸ್ಟ್ ಪೈಥಾನ್ ಅಲ್ಲಿ ನಂಬರ್ಸ್ ಆರ್ ನೇಮ್ಸ್ ಇನ್ ಅ ಫಿಕ್ಸ್ಡ್ ಸೈಜ್ ಗ್ರೂಪ್ at contiguous memory location. Stress on this point ಅನ್ನ ಸ್ಟ್ರೆಸ್ ಮಾಡಿ. Contiguous memory location. What does this mean? This means like image ಅಲ್ಲಿ ಟ್ರೈ ಮಾಡೋಣ, ನೋಡೋಣ ಸಿಗುತ್ತಾ ಇಲ್ವಾ ಅಂತ. Let's find any related. Yeah, this looks okay. Yeah, ಇದರಲ್ಲಿ what we defined.
Variable.
See, we declared an array and we initialize it to what? 1, 7 and 3. Okay, this is our main memory. That is what? RAM.
Hmm.
Okay, and these are the addresses of it.
Hmm.
ಈಗ ನಾವು ಅರೇ ಅನ್ನ ಡಿಕ್ಲೇರ್ ಮಾಡಿದ್ರೆ somewhere in between the main memory, that is at random addresses like 72, 76 and 80. Now here imagine, so this is what of type int. Therefore, how much is the byte difference here? 4.
Forward.
ಹೌದಾ? See,
Hmm.
at 0th position, what is the element? 1.
Hmm.
At 7th position, at first position, at first index, that is 7. At second index, that is 3. Now after this what happened is I wanted to add another element. ನಾನು ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಆಡ್ ಮಾಡಕ್ ಟ್ರೈ ಮಾಡ್ಬೇಕು, ಅಂದ್ರೆ ಮಾಡ್ಬೇಕಿತ್ತು actually. But what happened is we have defined the size of the array. See, we have defined the size of the array before itself. Therefore, what is the problem that I'm facing is, now this is a random access memory. Random access memory ಆಗಿದ್ರಿಂದ ಇಲ್ಲಿ we won't be having any space. Not always. Because ಇಲ್ಲಿ the memory might give space for another arrays or another variables which we declared in our program or something another. So this memory may be or may not be full. Okay, understanding, getting my point? Hello? Hello, hello. Okay. So 1, 7 and 3 ಇದು array ಅನ್ನ ನಾವು ಡಿಕ್ಲೇರ್ ಮಾಡಿದ್ವಿ, ಇನಿಷಿಯಲೈಸ್ ಮಾಡಿದ್ವಿ, and after that we may be having free space or we may not be having free space. Okay. Therefore, what is the problem we are facing? We cannot increase our elements or we cannot add new elements here. Here's where our linked list comes in. Okay, so what was the problem which we are facing in arrays? The memory problem, the declaration of arrays initially. ಮೊದಲೇ ನಾವು arrays the size ಅನ್ನ declare ಮಾಡ್ಬಿಟ್ವಿ. Therefore, we are unable to add new elements in it. So let's to solve this problem, what we did, uh, we took the help of linked list. So let's just type here what are linked list. A linked a linear data structure. Linked list is what? A linear data structure that stores a sequence of elements or nodes where each node contains both data and a pointer or reference to the next node in the sequence. ಈ definition ಅನ್ನ ಅರ್ಥ ಮಾಡಕ್ try ಮಾಡ್ಕೊಳ್ಳೋಣ. So let's take this simple image from Geeks for Geeks. So here what's happening? Illi, see, we have what? This is a linked list, or we could say this as what? A node. This is another node. This is another node. So it is written here node, node, node. So each node will be having two parts. This is what? Singly linked list. Singly linked list. Okay. So this is what? A head which has a data and an address which is pointing to our next node. Understand? So what is a linked list? See, what is the definition of the linked list here? A linear data structure. See, what is it? A linear data structure. So this is in what? A linear data structure that stores a sequence of elements or nodes where each node contains both data and a pointer. We have our data and we have our what? Pointer. That is what? Address which is pointing to next node. See, this is singly linked list. We have what? An data and a pointer which is pointing to next node. So the same happens here. We have a data and we have an address which is pointing to next node. Then we have a data and which is pointing to next node. We have again data and now it is not pointing anywhere. So what will define this as? We'll define this
Yes.
as null. Okay. Now here, see, this is what? This is the integer type. And this is what? Integer type again. Uh, it it's not mandatory that this is an integer number always, because we are defining pointer of type integer. Therefore, how many bytes will the address be? 4 bytes. And how many bytes will the data be? 4 bytes. So total size of this one node is what? 8 bytes. So total size of this 4 nodes is what? 8 into 4, that is 32 bytes. Okay. So now for first time when you see this linked list and memory allocations, you'll uh, you'll find out that for small amount of numbers, that is for small inputs, arrays size are very small when compared to linked list. But for very large inputs, very large amount of inputs, what happens? The size of arrays increases, whereas the size of linked list what decreases. Okay. Now, idanna when we understand big O notation and all, we'll try to learn it there. So adanna we'll take in next class something like that. So this was the basic idea of linked list. So this was the definition. It's a linear data structure. It's a linear data structure that stores a sequence of elements. There are a sequence of elements. This, all are what? Elements, or we could also call it as nodes. In C, we call it as nodes. Okay, nodes where each node contains both data and pointer. See, each node, this is a node which contains a data and a pointer. Okay, the pointer is pointing toward next element. So this was the basic idea of linked list. Okay, now this was what? Singly linked list. Okay, this is what? Singly linked list. Now we'll try to understand doubly linked list. Doubly linked list is a what? It's a type of linked data structure where each node contains a pointer to both. See, here stress on this, pointer to both the next and the previous node in the sequence, allowing for bidirectional traversal. Now, in our earlier case, what happened is we were only traversing in one path. That is, we can't even come back. Understood? Now, ಹಿಂದೆ ಬರಕ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ. We have to only move what? Forward. Getting my point? We were only moving forward. So this, let's take it from geeks for geeks. So this is what? This is a double pointer. We could start from here, so which is also known as head, and this is also known as tail, or we could say this is head and this is tail, doesn't matter because these are double pointers. So what it will do, see, let's take this node. This node has what? This node has a data, it has a pointer, it has a pointer, that are, it has two pointers and a data, where the next pointer is pointing to next what? Node, and the previous pointer is pointing to previous node. Here we can by what? Bi-directional traversal. What is traversal? Traversal is what? Uh, moving from I- what? Traversal is
Going through
what
each
we could
element.
say. Uh, Traversally is like seeing each element at least once.
Mm.
At least once. Let's just write the definition of traversal here and see. Visiting each element at least once. That is the basic definition of traversal. Let's see what Google offers. The process of visiting each elements of data structure, that is arrays linked list, that is exactly once in a systematic way. That is what our basic definition was. Visiting each elements at least once. That is what we could traverse from left to right, or we could traverse from right to left. Okay, these are what? These are doubly linked list. Doubly linked list has what? Both. That is data and two pointers which are pointing to next and previous. So this was a basic idea of what? Double pointers. And our basic idea of what single pointers was what? We could traverse it at least once, and we had a data and a pointer which is pointing to next node. Okay. Now let's try to understand how to implement this linked list in our C program. Okay. let's go over here. So this is a program which I don't know. ಈ program ಅನ್ನ ನಾನು ಇವತ್ತೇ ನೋಡ್ತಿರೋದು. I am seeing this program first time today only. Uh, so let's see whether we may be able to understand this program or no. Okay. So we have included input output stream and library, and we'll go directly to what main. So in main, what we're doing, struct node head. What we did, we defined struct, I guess. Before this main, yeah, that is what we defined struct. Now here one more comes. What is struct data type? Is it a data type? In C programming, a structure or struct is a user defined data type. What is it? A user defined data type that allows you to group together variables of different data, different types under a single name. Okay, so what a struct is? This is a data type. And what we'll call this data type? We are calling this data type as node, which has what? A data and a node, that is a pointer to node next, which is pointing to next struct, which is pointing to next node. Okay, getting my
Yes.
point?
Uh,
Int data, we have a struct node. See, this whole is what? Our node, or we could say what? An element for linked list. This is whole is what? A node of a linked list. We are defining this. So there is no data type such as linked list. We have to create it. You take any programming language, we have to create our own data types. So this is what a user defined data types. Now in this, according to our requirements, what we are implementing singly linked list. So what we'll do, we'll declare a data type int and we store data in it, and will declare a pointer to struct and will what? Point it to what? Next. So next is a pointer. We are defining a pointer, that is an arrow. Arrow is what? A pointer which is pointing towards next node. Okay, understood. Before main, we have to define this data type, because our main, because this does not include in standard library, we have to create this data type. Okay, and then let's move to main. So what we are doing here now, struct node head. We are we are what? Uh, we are initializing the struct node pointer to what? Head. Now node is pointing to what? Head, which is null, because we do not have any list. That is what this statement is trying to say. Num list create agilla. We did not create any list. Therefore, what is our next? That is our pointer pointing to. A pointer is pointing to null. Okay. Initialize head pointer to null. That is what we are doing, because we have an empty list. Therefore, our pointer is pointing to what?
None.
Null. Okay. After this, what we do? We will create some nodes manually. So head equals create node 10. So create node 10 is a function. Let's go there. Where is create node? Yeah, here struct node. See, this is a pointer type. So what will this create node return? It will return pointer type node. Okay, this is a return type, no? In C plus or C language, this is a return type. Return type is what? A pointer. Okay, let's create node int data. We sent data, that is 10. We sent 10. We received 10 here. Now struct node, new node. What we can write this also as temp. That is temporary node, or we could write is that new node. New node equals to what? We are allocating a memory for this new node. So now what is this malloc function doing? Malloc function is returning a void pointer. Malloc function will do what? It will allocate a memory in your RAM and it will give the pointer to new node. Understood what is happening here? Just try
yes,
to visualize with me that what is happening is RAM is malloc is what a struct node. So how many bytes will it be? Data plus next pointer, that is 8 bytes. Malloc is what? Malloc is providing 8.8 bytes, and what it is pointing a pointer towards 8 bytes. At that pointer is what it is returning to new node. So what does new node hold now? New node holds the address of a memory in our RAM which is of size 8 bytes, which is provided by which function? Malloc function. Okay, now understood what is happening here? ಅರ್ಥ ಆಯ್ತಾ?
yes, yes,
Huh. So I'll just simplify it. Malloc is what? It is providing some space and it is pointing a pointer to that space and we are receiving that pointer. That's it. That's the definition of this new node. Struct node star new node. This is the basic definition of it. Okay, we have already deal with malloc in our previous matrix multiplication. So malloc should be now easy for you guys.
mm,
Okay, after this, what we are checking if new node equals to null. That is, if memory is really allocated or not. Memory, if memory is not allocated, then what? We cannot store our data. Understood?
yes,
ಸೊ ಮೆಮೊರಿ ಅಲೋಕೇಟ್ ಆಗಿದೆನೋ ಇಲ್ಲೋ ಅಂತ ನೋಡ್ತಿದ್ದೀವಿ. ಇಫ್ ಈಕ್ವಲ್ಸ್ ಟು ನಲ್ ಅಂದ್ರೆ ಮೆಮೊರಿ ಅಲೋಕೇಟ್ ಆಗೇ ಇಲ್ಲ ಅಂದ್ರೆ ಮೆಮೊರಿ ಅಲೋಕೇಶನ್ ಫೇಲ್. ಮೆಲಾಕ್ ಅಲ್ಲಿ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಇರ್ಬೋದು, ಸೊ ಆರ್ ವಿ ಕುಡ್ ಹ್ಯಾವ್ ಸಮ್ ಸಿಂಟ್ಯಾಕ್ಸ್ ಎರರ್ ಆರ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಟ್. ಓಕೆ, so here what we are checking if the allocation was successful or not. Now here comes our main what we say, assigning the values. So initially what we did, we received data. What is the data we received?
then,
Data, we received it as 10. So what we'll do, we could write it as this new node. New node is now what? Empty. New node is a data structure which has what? Which has data, space for data and space for next pointer. Pointer of name next. Okay. ಸೊ ನ್ಯೂ ನೋಡ್ ಅಲ್ಲಿ ಡೇಟಾ ಅನ್ನ ನಾವು ಏನ್ ಕೊಡ್ತಿದ್ದೀವಿ? ವಿ ಆರ್ ಗಿವಿಂಗ್ ಇಟ್ ಆಸ್ ಡೇಟಾ. ದಟ್ ಈಸ್ ವಾಟ್ ಇಟ್ ಈಸ್ ಸ್ಟೋರಿಂಗ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ 10. ಓಕೆ, ಅಂಡರ್ಸ್ಟುಡ್ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್? ನ್ಯೂ ನೋಡ್ ಒಂದು ಹೊಸ ನೋಡ್ ಅಂಡ್ ದಿಸ್ ನ್ಯೂ ನೋಡ್ ಒಳಗಡೆ ವಿ ಹ್ಯಾವ್ ಡೇಟಾ ಅಂಡ್ ನೆಕ್ಸ್ಟ್, ಸೇಮ್ ಆಸ್ ದಿಸ್ ಸ್ಟ್ರಕ್ಟ್ ನೋಡ್. ಅರ್ಥ ಆಯ್ತಾ? ಈ ನ್ಯೂ
yes,
ನೋಡ್ ಒಳಗಡೆ ವಿ ಹ್ಯಾವ್ ಡೇಟಾ ಅಂಡ್ ವಿ ಹ್ಯಾವ್ ನೆಕ್ಸ್ಟ್. ಸೊ ಈ ನ್ಯೂ ನೋಡ್ ಒಳಗಡೆ ವಿ ಆರ್ ಅಸೈನಿಂಗ್ ಅ ಡೇಟಾ ಟು ವಾಟ್? ದ ಡೇಟಾ ವಿ ರಿಸೀವ್ಡ್ ಹಿಯರ್, ದಟ್ ಈಸ್ 10. ಅಂಡ್ ನ್ಯೂ ನೋಡ್ ಇಂದು ಪಾಯಿಂಟರ್ ಯಾರಿಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ತಿದೆ? ನಲ್ಲಿಗೆ. ವೈ ನಲ್? ಬಿಕಾಸ್ our user gave only one input, that is 10. Therefore, what we are pointing our next to what? Null. Because here our list has ended. Understood? Now here what we will return? We will return our new node. So what does new node hold now? Let's write it here. New node. New node has data which is equals to 10 and next which is a pointer. So if brackets in the confuse ಆಗ್ಬಿಟ್ಟು, this is for my understanding. Okay, equals to what? Null. Understood what is happening? New node ಒಳಗಡೆ, new node has not had, okay, has data which is 10 and a pointer which is null. Okay, understood what is happening? Understood or no?
No, understood.
Huh. After this, what we are doing, we are traversing the list. Now, ಏನಪ್ಪಾ ಅಂದ್ರೆ we have a list here. Let's say ಇಲ್ಲಿ we have one node which is pointing to um, new node. So this is our end of the list. This was our node, and this is our new node, which is of type struct. And this has what? This has data equals 10 and next, which is pointing to null. Okay. Now, what this means is our head is what? This node. This node is what? Our head. Howda? Is this correct or not? ಅರ್ಥ ಆಗ್ತಿದೆನಾ? ಐ ಹೋಪ್.
Mm.
ನೀವು ಹಿಂಗ್ ಮಾಡಿದ್ರೆ ನನಗೆ ಗೊತ್ತಾಗಲ್ಲಲ್ಲಿ. ಯು ಹ್ಯಾವ್ ಟು ಸ್ಪೀಕ್.
Understood.
ಹಾ, ಅಷ್ಟಾದ್ರೂ ಹೇಳ್ರಿ. Node, node is what? Our head. So what we are doing here, we are pointing our head to next. That is what? Now node head ಆಗಿತ್ತು. We are traversing the list to what? New node. ಈಗ new node is our new head. So list starts from where? From here. ಇಲ್ಲಿಂದ ನಮ್ಮ ಹೊಸ ಲಿಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಿದೆ. ಸೊ ದ ರೀಸನ್ ವೈ ವಿ ಆರ್ ಟ್ರಾವರ್ಸಿಂಗ್ ಇಸ್, ನಾವು ಇಲ್ಲಿಂದನೇ ಹೆಡ್ ಈಕ್ವಲ್ಸ್ ಟು ಮತ್ತೆ ಕ್ರಿಯೇಟ್ ನೋಡ್ ಫಂಕ್ಷನ್ ಅನ್ನ ಕರೆದ್ವಿ ಅಂದ್ರೆ ಇಲ್ಲಿಂದಾನೆ ಮತ್ತೆ ನಮ್ಮ ಪಾಯಿಂಟರ್ ಇನ್ನೊಂದು ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್ ಹೀಗೆ ಪಾಯಿಂಟ್ ಮಾಡಿಬಿಡುತ್ತೆ. ವಿ ಡೋಂಟ್ ವಾಂಟ್ ದಟ್. ವಿ ವಾಂಟ್ ವಾಟ್? ವಿ ವಾಂಟ್ ಆರ್ ನ್ಯೂ ನೋಡ್ ಟು ಪಾಯಿಂಟ್ ಟು ನೆಕ್ಸ್ಟ್ ನೋಡ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಅರ್ಥ ಆಯ್ತಾ? So what we are doing, we are traversing it. So this is nothing but we are traversing it. We could write it using while loop also. Let's see further when we deal with complex types, we'll use while loop and all. Okay. Now what we did, we traversed to our last node in our list. What is our last node in our list? That is our first node, because we only created one node in our list, that is data 10 and next null. Okay. Now we went where? To our first node, which is our head. See, there will be a head and there will be a node. Head is pointing to node. We traverse it. We went to new node, and what we called this function? Create node. Now let's go to create node. Create node ali. What is the data which the user passed? That is 20. Yeah. The data which the user passed is 20. Let's write it over here. And what we did struct node equals new node. ಹೊಸ node ಅನ್ನ create ಮಾಡಿದ್ವಿ ನಾವು ಮತ್ತೆ. So here what we had did, we had returned what? New node. So new node in pointer head ಗೆ point ಆಗ್ತಿದೆ. So what is this now? This is head. Okay, understood? Now ಇಲ್ಲಿ struct node new node, again we'll do the same process. We are allocating some memory which is of size struct node, and then we'll check if the memory is really allocated or not, and then we'll what? Store the data, that is what? 20 in our new node. ಇದನ್ನ ನಾವು ಯಾವ ತರ ಬರಿಬಹುದು ಅಂದ್ರೆ, you could write it as like this: star new node dot data, capital N, star new node data equals data. ಈ ತರ ಆದ್ರೂ ಬರಿಬಹುದು, or we could just put an arrow mark. both are the same.
A.
Okay, this arrow mark is for our better understanding. ಈ ತರ ಪ್ರತಿ ಟೈಮ್ ಬರೆದ್ರೆ ವಿಲ್ ಗೆಟ್ ಅ ಲಿಟ್ಲ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಓಕೆ, ಈ
A.
ತರ ಆದ್ರೂ ಬರ್ಬೋದು, ಈ ತರ ಆದ್ರೂ ಬರ್ಬೋದು. So what is our new node data? That is 20, and our next pointer is pointing to what? Null. Okay, understood. And now what we are returning? New node. So here now you might be thinking, ಇಲ್ಲಿ ಏನಾಯ್ತಂದ್ರೆ we had a node which is pointing to what? A new node which has some value in it, and now this is pointing to what? This is still not pointing. See what happened here is, it is new node, it is pointing to what? Null. It is pointing to null. Our next is pointing to null. ಬಟ್ ಈ ಎಲ್ಲ ಸಿನಾರಿಯೋದಲ್ಲಿ ನಾವು ವಿ ಡಿಡ್ ನಾಟ್ ಪಾಯಿಂಟ್ ದಿಸ್ ಹೆಡ್. ಇದು ಹೆಡ್. ಈ ಹೆಡ್ ಇಂದು ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟರಿಗೆ ನಲ್ ಅಂತ ನಾವು ಪ್ರೀವಿಯಸ್ಲಿ ಅಸೈನ್ ಮಾಡಿದ್ವಿ. ಬಟ್ ಈ ಕೇಸಲ್ಲಿ ವಿ ಡಿಡ್ ನಾಟ್ ಅಸೈನ್ ದ ಪಾಯಿಂಟರ್. ಈ ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟರಿಗೆ ಪಾಯಿಂಟೇ ಮಾಡ್ತಿಲ್ಲಲ್ಲ ನಾವು. ವಿ ಡೈರೆಕ್ಟ್ಲಿ ಡಿಡ್ ಹೊಸ ನೋಡನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ವಿ. ಆ ಹೊಸ ನೋಡಿಂದು ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟರ್ ಅನ್ನ ನಲ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ. ಬಟ್ ಪ್ರೀವಿಯಸ್ ಪಾಯಿಂಟರ್ ಇಂದು ಪಾಯಿಂಟರ್ ಈ ಹೊಸ ನೋಡಿಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ಬೇಕಲ್ಲ, ಅದು ಎಲ್ಲೂ ಡಿಫೈನ್ ಆಗಿಲ್ಲಲ್ಲ ಇಲ್ಲಿ. ಬಟ್ ಸ್ಟಿಲ್ ದ ಕೋಡ್ ಇಸ್ ವರ್ಕಿಂಗ್. ವೈ ಇಸ್ ದಟ್? ಎನಿ ಐಡಿಯಾ? ಸಿ, ಐಲ್ ಫ್ರೇಮ್ ದ ಕ್ವಶನ್ ಅಗೇನ್. ನಾವು ಒನ್ ನೋಡ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ, ಅದರಲ್ಲಿ ಸಮ್ ಡೇಟಾ ಇತ್ತು, ಮತ್ತೆ ವಿ ಹ್ಯಾಡ್ ಅ ಪಾಯಿಂಟರ್ ವಿಚ್ ವಾಸ್ ಪಾಯಿಂಟಿಂಗ್ ಟು ನಲ್. ಓಕೆ, ನಾವು ಅದನ್ನ ಸೈಡಿಗೆ ಇಟ್ಟು ವಿ ಕ್ರಿಯೇಟೆಡ್ ಅ ನ್ಯೂ ನೋಡ್ ಅಗೇನ್. ಹೊಸ ನೋಡ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ವಿ, ಮತ್ತೆ ಅದರದ್ದು ಡೇಟಾ ಬೇರೆ 20, ಮತ್ತೆ ಅದರದ್ದು ಪಾಯಿಂಟರ್ ನಲ್ಲಿಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ತಿದ್ದೀವಿ. ಬಟ್ ಹೌ ಇಸ್ ದ ನೋಡ್ 1 ಪಾಯಿಂಟಿಂಗ್ ಟು ನೋಡ್ 2? ಹೌ ಇಸ್ ಇಟ್? How is the node 1 pointing to node 2, whereas we didn't define here that node 1 should point to node 2?
W.
Huh? Any idea what is happening? What is happening? What might be wrong or what might be correct? How is the code working? See, I'll tell you. See, before we allocate the next node, what we did, we traversed. Okay, so when the first node returned, ಅಂದ್ರೆ ಫಸ್ಟ್ ನೋಡ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ನಾವು ನ್ಯೂ ನೋಡ್ ಅನ್ನ ರಿಟರ್ನ್ ಮಾಡಿದಾಗ, ದ ಪಾಯಿಂಟರ್ ಅಡ್ರೆಸ್ ಅಂದ್ರೆ ದಿಸ್ ವಾಸ್ ಆರ್ ಪ್ರೀವಿಯಸ್ ಹೆಡ್. ಓಕೆ, ದಿಸ್ ವಾಸ್ ಆರ್ ಪ್ರೀವಿಯಸ್ ಹೆಡ್ ಅಂಡ್ ದಿಸ್ ವಾಸ್ ಪಾಯಿಂಟಿಂಗ್ ಟು ಆರ್ ನ್ಯೂ ನೋಡ್. ಓಕೆ, ಗೊತ್ತಾಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ? ದಿಸ್ ವಾಸ್ ಆರ್ ಹೆಡ್. ಹೆಡ್ ಅಂದ್ರೆ ವಾಟ್? It is the initial list from where the list starts. Initial node from where the list starts. Okay, so initially node was our head, and when we returned the pointer, what was it pointing to? It was pointing to new node. Artha aata?
Yes.
Now what we did, when we were giving a new node, what we did, we traversed it to what next? Andre now this new node will be our new head.
Yes.
Godata, this will be our new node, will be our new head. And when we call this create node function, what will this return? It will return again new node. ಈ ರಿಟರ್ನ್ ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ? It will directly go to head. But what is our head? Our head is not node. Our head is previous node. That is our first node. Godata? This node does not have any data. It is just pointing to our beginning of the list. ಅರ್ಥ ಆತಾ?
Hmm.
Now when we traverse, what happened is ಇಲ್ಲಿಗೆ ನಮ್ಮ ಹೆಡ್ ಇದ್ದಿದ್ದು, that head moved from here to what? Here. Now this is a new head. Now what, when it returned the pointer to directly what? This. ಇಲ್ಲಿಗೆ our second node ಇಂದು ಏನಾಗುತ್ತೆ? ಪಾಯಿಂಟರ್ ಹೋಗುತ್ತೆ. So now what this will be pointing to? Second node. And what will it have? Data, which is equals to 20, and next, which is equals to none. ಗೊತ್ತಾಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ ಏನ್ ಆಗ್ತಿದೆ ಇಲ್ಲಿ ಅಂತ? ಅರ್ಥ ಆಯ್ತಾ? I hope you are understanding it. ಅಂದ್ರಲ್ಲಿ ಅಪ್ಪ, I am unable to hear you guys. ನೋಡಕ್ಕೂ ಆಗಲ್ಲ. ಓಕೆ, ನಾವು ಏನಾಯ್ತು, ಹೆಡ್ ಅನ್ನ ಮೂವ್ ಮಾಡಿದ್ವಿ ಇಲ್ಲಿ. ಓಕೆ, ನಾವು ಕ್ರಿಯೇಟ್ ನೋಡ್. ನಾವು ವಿ ಆರ್ ಕಾಲಿಂಗ್ ದ ಕ್ರಿಯೇಟ್ ನೋಡ್ ಅಗೇನ್. ಇನ್ನೊಂದ್ಸತಿ ಕಾಲ್ ಮಾಡ್ತಿದ್ದೀವಿ ಕ್ರಿಯೇಟ್ ನೋಡ್ ಅನ್ನು. Now what we did, now we are traversing it again. Now earlier, where was the head? It was here. When we called second time, where was our head? It was here. Now the third time we are calling create node, where will our head be? We have to traverse it. Our head will be where? Here. Understood? So next ಈಗ ನಾವು ಮತ್ತೆ create node function ಅನ್ನ ಕಾಲ್ ಮಾಡಿದಾಗ what happens? It allocates some memory that is of size struct node, and it checks whether the memory is allocated or not, and it provides the data. What was the data we passed? Probably 30. And now our new node will be holding what data? 30 and null. And what will it return? What will this function return? It will return new node. Now where will this new node pointer go? It will directly go over here. That is our third node. So ಈ ನೋಡ್ಸ್ ಇನ್ನು ನೇಮ್ಸು, ನ್ಯೂ ನೋಡು, ಸೆಕೆಂಡ್ ನೋಡ್ ಈ ತರ ಇರಲ್ಲ. It will be just in the type of what? A data and a pointer. A data and a pointer. This is for our understanding. Okay, don't get confused with that. Sarina, this third node will be holding what? Data, data. That is what? Data 30. 30, no? Yeah, 30. And next equals none. So this is what? End of our list. ಇಷ್ಟೇ ಕಾಲ್ ಮಾಡಿದ್ದ ಯೂಸರ್. ಸೊ our user created a linked list. ಈ ತರ ನಾವು ಮಾಡ್ಬೋದು. ಅಥವಾ we could write a while loop. We'll see now. Further, when we deal with large lists deal ಮಾಡುವಾಗ we have to write while loop. ಸುಮ್ಮನೆ ಹಿಂಗೆ ನೆಕ್ಸ್ಟ್ ಬರ್ಕೊಂತ ಹೋದ್ರೆ we will at one point this space complexity occurs. We'll learn about space complexity and time complexity in a complete new video. Okay, so this in what was the aim of this program? How the linked lists are implemented? Batata. A linked list is not a data type. It is a data structure. It is a structure where we are storing our data. Understood? A linked list is not a data type. It is what? A data structure. Artha? Now there is one function remaining. That is what? Display list, which is what? Head. Iga we will go to this. Illi hoganante. Display list. Yeah, this is it. What we are passing? We are passing head to it. Head. What is our head now? Our head is not this. Next third node is not our head. Node is our head. ಗೊತ್ತಾತಾ?
Hmm.
As soon as this terminates, as soon as this create node terminates, that is this function terminates, our head will shift to what again? Node. So what is our head? This node. ಈ ನೋಡ್ ಒಳಗಡೆ ಏನಿದೆ? Just a pointer, no data type, no data, just a pointer which is pointing to what? Start of the linked list. ಇಲ್ಲಿಂದ ನಮ್ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ, but our head is what? Pointing to the start of our linked list. ಅರ್ಥ ಆತಾ? Now display ಅಲ್ಲಿ we are passing our head, that is node. Display is what here? Struct node temp equals head. Now why we are doing this? Temp ಅಂತ ಒಂದು ಹೊಸ ಸ್ಟ್ರಕ್ಚರ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಅದಕ್ಕೆ ಹೆಡ್ ಅನ್ನ ಇನಿಷಿಯಲೈಸ್ ಮಾಡ್ತಿದ್ವಿ. ಯಾಕೆ? See, I'll tell you why. ಈಗ ನಾವು ಹೆಡ್ ಅನ್ನೇ ಟ್ರಾವರ್ಸ್ ಮಾಡಿಬಿಟ್ರೆ our head will what? Our head will move from node to new node, from new node to next node, from next node to third node. Our head will move toward third node. And next time when we add here a new statement, our head will be directly here. And when we add head dot next to dot next dot next, then it will give us error, because dot next does not exist only because our head is directly pointing to this. Therefore, what we did, we created a new pointer. Node alli, our head is pointing to node. That is, node is our head. Okay. Now what we did, head ಅನ್ನ temp ಅಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ ನಮ್ ಅವಶ್ಯಕತೆ ಏನಿತ್ತು ಅಂದ್ರೆ, now we have two pointers. One is head pointer which is pointing to node, and one is temp pointer which is pointing to node. Understood? Now because we don't want to change our head, we took a new pointer temp which we will traverse and print. ಗೊತ್ತಾಯ್ತಾ? We don't want to change our head, that is why we took a pointer and we are traversing it. We are traversing it to what? Print. Okay, now let's see. If temp is null, ಅಂದ್ರೆ ನಾವು ಈ ಫಂಕ್ಷನ್ ಏನು ಕಾಲೇ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ head will be what? Null. If head is null, what? List was what? Empty. But after that, what we did, we gave some values to our list. We created 3 nodes in our list. So what does this definition do? It's just checking whether our temp is empty or not. That is, our list is empty or not. If it is null, then it will print list is empty. If not, then it will print the linked list is, and now we are again what? Traversing here. So this is what? Traversing. Traverse the list until we reach the end. We could write the same while loop over here. Understood?
Okay.
Now temp use ಮಾಡೆ same while loop ಅನ್ನ ಇಲ್ಲಿ ಬರೆದು our head will be here only. ಇಲ್ಲೇ ಇರುತ್ತೆ ನಮ್ಮ head. And our head will be pointing to node. And temp ಅನ್ನ ನಾವು ಇಲ್ಲಿ ತನಕ ತಗೊಂಡು ಹೋಗಿ, after taking the temp pointer to our last node, again we will create a new node. ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ, our next node will be pointing to temporary, and that temp will be pointing to what? Next node, and we will eliminate temp again. ಅರ್ಥ ಆಯ್ತಾ what I'm trying to say? So instead of that, what directly we shifted head ಅನ್ನ directly shift ಮಾಡಿದ್ವಿ, and we called this function. But illi, while we are printing, we don't want our head to be what? Now head ಅನ್ನ change ಮಾಡಬಾರ್ದು ನಮ್ಮ motto. That is why we are taking a new print ಏನಂತಾರೆ pointer. We are taking a new pointer, and what we are pointing it to? Node. And we are traversing it. Traversing. See, while traversing itself, we are printing it. ಗೊತ್ತಾಯ್ತಾ? While traversing itself, one time traverse. See, temp null ಆಗ ತನಕ print ಮಾಡು. ಅಂದ್ರೆ while loop run ಮಾಡು. Understood? What is this?
Hmm.
Unless our temp becomes temp points to null, keep this loop alive. Understood? Basic definition. ಇದ್ರದ್ದು ಏನ್ ಅರ್ಥ ಅಂದ್ರೆ ಟೈಪ್ ನಾಟ್ ಈಕ್ವಲ್ ನಲ್, ಇದ್ರದ್ದು ಏನ್ ಅರ್ಥ ಅಂದ್ರೆ ಅನ್ಲೆಸ್ ಆರ್ ಟೆಂಪ್ ಬಿಕಮ್ಸ್ ನಲ್ ವೈಲ್ ಲೂಪ್ ರನ್ ಮಾಡ್ತಾ ಇರೋ ಅಂತ. ಅಂಡ್ ನಾವು ಒನ್ಸ್ ದ ವೈಲ್ ಲೂಪ್ ಸ್ಟಾರ್ಟ್ಸ್, ಒಂದ್ಸತಿ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು, ವಿ ವಿಲ್ ಪ್ರಿಂಟ್ ವಾಟ್ ವಿ ವಿಲ್ ಪ್ರಿಂಟ್ ಟೆಂಪ್ ಡೇಟಾ. ಟೆಂಪ್ರರಿ ಅಲ್ಲಿ ಡೇಟಾ ಏನಿದೆ ಈಗ, ವಿ ಹ್ಯಾವ್ 10. See, because temp is what? Pointing to new node. ಗೊತ್ತಾತಾ?
Hmm.
So what will it print? 10. 10 print ಮಾಡ್ತು. Okay, now after printing 10, printf ಆದ್ಮೇಲೆ temp equals to temp dot next. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, our temp is now traversed to what? Here. ನಾವು ನಮ್ temp ಏನಿತ್ತು ಇಲ್ಲಿಗೆ ಹೋಯ್ತು. ಅರ್ಥ ಆತಾ? So earlier
Hmm.
our temp was here. Now what this new statement did, temp equals temp dot next. Now the reason why I'm calling this arrow as dot is because we could write it like this also, as I said. So therefore instead of saying arrow, I'm just saying dot. Okay, temp dot next ಅಂದ್ರೆ ನಮ್ temp ಇಲ್ಲಿಗಿದ್ದಿದ್ದು it moved from here to here. Now what is a new temp? Our second node in the list. Understood?
Hmm.
So now is temp equals to null? Temp not equals to null. That is true. Temp is not equals to null because we still have our second node to print. Therefore this while loop does not terminate. And what we'll do, we'll print again. ಈ temp ಅಲ್ಲಿ ಏನ್ ಡೇಟಾ ಇದೆ ಈಗ?
20.
20 ಇದೆನಾ? We will print what? 20. So first what did it print? It print 10. And then next what is it printing? It's printing 20. Now temp equals temp dot net ಅಂದ್ರೆ temp dot next ಅಂದ್ರೆ ಇಲ್ಲಿ ಇರೋದು ನಮ್ಮ ಪಾಯಿಂಟರ್ ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ ನೆಕ್ಸ್ಟ್?
Third no.
ಥರ್ಡ್ ನೋಡಿಗೆ ಹೋಗುತ್ತೆ. ಅಂಡರ್ಸ್ಟುಡ್? ನಾವು ವಾಟ್ now you might be getting a clear idea. Our temp was earlier pointing to head. We traversed it to our first node, then we traversed it to our second node, and we traversed it to our third node. Now where is our temp? Our temp is at third node. Okay,
Third no.
and third node ಅಲ್ಲಿ ಇದೆ ನಮ್ಮ temp. And where is our head? Here itself. Head did not change at all.
Hmm.
ಗೊತ್ತಾಯ್ತಾ? Now what we did, temp equals temp dot net traverse ಮಾಡಿದ್ವಿ. Then ಮತ್ತೆ while loop ಅನ್ನ ನೋಡೋಣ. Temp is not equals to null. That is correct. ಯಾಕಂದ್ರೆ we still have one more node, that is third node to be printed. So printf ಏನ್ ಮಾಡೋಣ? Third node, that is what? 30 ಅನ್ನ print ಮಾಡೋಣ. Okay, 30 ಅನ್ನ print ಮಾಡೋಣ. After printing 30, temp equals temp dot next. Now here what happens? Next node andre temp is where now? Temp is over here. This
Hmm.
is a temp. Now this temporary structure is pointing to now where?
Null.
Null. It is pointing to null. ಹೌದಾ? So is temporary not equals to null? ಹೌದಾ? No, false. Because temporary is equals to null. Now what was our syntax of while loop? Our while loop executes the loop only when the condition is true. Here condition failed. Therefore this while loop, what it did? It
Printf
terminated.
fail.
It failed. It terminated. So here our while loop ended. Now what did we get? We got 10, we got 20, and we got 30. Okay.
Uh,
Now, one thing you have to remember here. Now, each time when we call this function, we were what next element ಅನ್ನ next node ಅಲ್ಲಿ ಮತ್ತದರ next element ಅನ್ನ next node ಅಲ್ಲಿ store ಮಾಡ್ತಿದ್ವಿ. But we could do this opposite also. We could do it something like this. 10 would be our last element. ಮತ್ತೆ 20 ಅನ್ನ 10 ಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ಬೋದಿತ್ತು, 30 ಅನ್ನ 20 ಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ಬೋದಿತ್ತು. That is our new element would be what? 30 and 20 and 10.
10.
This concept is what? Inserting a node at the beginning of the list.
Uh,
ಅದನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನೋಡೋಣ, ಟ್ರೈ ಮಾಡೋಣ. ಅಥವಾ ಇದೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳ್ರಿ ಅಂದ್ರೆ ಇಲ್ಲೇ ಐತಿ, ವಿ ಕುಡ್ ಜಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್. ಬಟ್ ದಿಸ್ ಇಸ್ ಅ ಬಿಗ್ ವಾಟ್ ದಿಸ್ ಇಸ್ ಅ ಬಿಗ್ ಪ್ರೋಗ್ರಾಮ್, ಸೊ ವಿ ನೀಡ್ ಸಮ್ ಟೈಮ್ ಫಾರ್ ಇಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. Okay, that is
uh,
what that was inserting a node at the beginning. This is what inserting a node at the end of the list. Artha aata?
Hmm. Hmm.
After this while loop terminates, we print null, which indicates end of our list. Now, for our better understanding, what I'll do, head which points to next, again which points to next, again which points to next. Now ಇದನ್ನ create node ಅನ್ನ ಕೊಟ್ಟು will write 40 over here for just our better understanding. Okay.
uh,
ಈಗ ನಮ್ಮ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ನೋಡ್ ಇದಾವೆ?
4.
4
Uh,
4.
ಓಕೆ, 4 ನೋಟ್ಸ್ ಇದಾವೆ.
ಹ್ಮ್
ರಿಟರ್ನ್ ಆದ್ಮೇಲೆ ಇದು ಬರ್ಬೇಕಲ್ಲ. ಯಾ, ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕರೆಕ್ಟ್ ಆಯ್ತಾ? ಐ ಮೀನ್ ಯಾ, ಈಗ ಕರೆಕ್ಟ್ ಆಯ್ತಾ? ಲೆಟ್ಸ್ ಚೆಕ್ ಇಟ್. ಇಲ್ಲಿಂದ ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಸ್ಟಾರ್ಟ್ 1 2 ಬ್ರಾಕೆಟ್ಸ್ 1 2 ಬ್ರಾಕೆಟ್ಸ್. ಇದು ಇಫಿಗೆ ಇಲ್ಲಿಂದ ಬ್ರಾಕೆಟೇ ಇಲ್ಲಲ್ಲ, ಇದು ಕ್ಲೋಸ್ ಮಾಡೋಕ್ಕೆ. ಓಕೆ, ಇದು ಕ್ಲೋಸ್ ಆಯ್ತು. ದಿಸ್ ಓಕೆ ಆ್ಯಂಡ್ ದಿಸ್ ಓಕೆ. ಈಗ ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕರೆಕ್ಟ್ ಇದೆ.
uh,
ಈಗ ನಾವು ವೆನ್ ಐ ಟ್ರೈ ಟು ಸೇವ್ ದಿಸ್ ಆ್ಯಂಡ್ ರನ್ ದಿಸ್, ಇದನ್ನ ರನ್ ಮಾಡಕ್ ಟ್ರೈ ಮಾಡ್ತೀನಿ ನಾನೀಗ. gcc what prg1.c output as prg1.exe. Okay, our it is created now. We'll print prg1 ಅಷ್ಟೇ. We will print it. See what we got, 10. ಕಾಣಿಸ್ತಾ ಇದೆನಾ?
uh,
ಹೋಪ್ ಇಟ್ಸ್ ವಿಸಿಬಲ್ ಫಾರ್ ಯು ಗೈಸ್. ಇದನ್ನ ಝೂಮ್ ಮಾಡೋಕ್ಕೂ ಬರಲ್ಲ ನನಗೆ.
ಕಾಣಿಸ್ತಿದೆ.
ಕಾಣಿಸ್ತಿದೆ ಅಲ್ಲ?
uh,
ವಾಟ್ ಆರ್ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ಏನು 10 and which is pointing to what? 20. That 20 is pointing to what? 30. And that 30 is pointing to what? Null. And 30 is pointing to what? 40.
Pointing to.
And that 40 is pointing to what? Null. ಗೊತ್ತಾತಾ?
uh,
ಇದರಲ್ಲಿ ಎಷ್ಟು ಗೊತ್ತಾತಾ? ನಾವು null ಆದ್ಮೇಲೆ it is not pointing to anything. Therefore, our list got terminated. That is our list, that this is the end of our list. ಅರ್ಥ ಆಯ್ತಾ?
Hmm.
uh,
So this was ಅಬೌಟ್ ಪಾಯಿಂಟರ್ಸ್ ಅಂಡ್ ಲಿಂಕ್ ಲಿಸ್ಟ್. ಯು ಸಿ ಪಾಯಿಂಟರ್ಸ್ ಇಲ್ಲ ಅಂದರೆ ನಾವು ಲಿಂಕ್ ಲಿಸ್ಟ್ ಮಾಡೋದು ಭಾಳ ಕಷ್ಟ.
ಹೌದು.
ದೇರ್ ಫಾರ್ ಪಾಯಿಂಟರ್ಸ್ ಒಂದ್ಸತಿ ಹೇಳಿದ್ರು ನಾನು ಇನ್ನೊಂದ್ಸತಿ ಹೇಳಕ್ಕೆ ಟ್ರೈ ಮಾಡಿದೆ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅ ವೆರಿ ಕಾಂಪ್ಲೆಕ್ಸ್, ನಾಟ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಬಟ್ necessary topic for our understanding. Okay, so this was it for today, I guess.
ಓಕೆ
ಅರ್ಥ ಆಯ್ತಾ?
ನೆಕ್ಸ್ಟ್
ಮತ್ತೆ
ಮೊನ್ನೆ
ನೆಕ್ಸ್ಟ್
ಮಾಡೋಣ.
ಮಂಡೇ
ಹ್ಮ್
ಸಿಗೋಣ ಅಂತೆ. ಮಂಡೇ ವಿಲ್ ಡೂ ಸಮಥಿಂಗ್ ಬಿಗ್,
ಓಕೆ
ಮಂಡೇ.
ಏನ್ ಮಾಡೋಣ?
ಮಂಡೇ ಅಂದರೆ ಮಂಡೇ ಈ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡೋಣ.
ಯಾವ
ಐ ಹೋಪ್ ಇದರಲ್ಲಿ ನಾನು ಬರ್ದಿಲ್ಲ ಆ ಪ್ರೋಗ್ರಾಮ್, ಐ
ಆಗ್ತಿದೆ.
ಶೋ ಯು. ನೋಡಿ ಯಾವ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡೋಣ ಅಂದರೆ ಮೆಮೊರಿ ಅಲೋಕೇಶನ್ ಲೂಪ್ ಅಂತ ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಇದೆ.
ಹ್ಮ್
ಈ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡೋಣ.
ಆಗ್ತಿದೆ ಬೇಕು
ಹಾಕಿನಿ.
ಆಗ್ತೀಯಾ?
ದಟ್ಸ್ ಆಲ್ರೆಡಿ ಇನ್ ಗಿಟ್. ಇದು ಮೆಮೊರಿ ಕಂಪ್ಲೀಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅಡ್ವಾನ್ಸ್ಡ್ ಮೆಮೊರಿ ಬೇಸ್ಡ್ ಲಿಂಕ್ ಲಿಸ್ಟ್. ಇದು ಪ್ರಾಬಲಿ ಡಬ್ಲಿ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಮೇಲೆ ಅಥವಾ ಸಿಂಗ್ಲಿ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಏನೋ ಗೊತ್ತಿಲ್ಲ. ಐ ಡಿಡ್ ನಾಟ್ ಸಿ ದಿಸ್. ನಾನು ನಿಮ್ಮ ಜೊತೆನೇ ನೋಡ್ತೀನಿ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಟ್ರೈ ಮಾಡ್ತೀನಿ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಇದು ಏನಿತ್ತಲ್ಲ ಕೋಡ್, ಇದು ನನಗೆ ಗೊತ್ತಿರಲಿಲ್ಲ. ಇವತ್ತೇ ನೋಡಿ ಇವತ್ತೇ ನಿಮ್ಮ ಜೊತೆನೇ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ದಿಸ್ ಇಸ್ ಹೌ ವೆನ್ ವಿ ಟ್ರೈ ಟು ಟೀಚ್ ನಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಇದು ಪ್ರೋಗ್ರಾಮ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಅಡ್ವಾನ್ಸ್ಡ್ ನೋಡ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. ನೋಡಿ, ವ್ಯಾಲಿಡ್ ಡೇಟಾನ ಮಾಡ್ತಿದ್ದೀವಿ, ನೆಕ್ಸ್ಟ್ ಅಂತ ಮಾಡ್ತಿದ್ದೀವಿ, ಪ್ರೀವಿಯಸ್ ಅಂತಲೂ ಮಾಡ್ತಿದ್ದೀವಿ. ಸೊ ದಿಸ್ ಇಸ್
ಡಬ್ಲಿ ಲಿಂಕ್ ಲಿಸ್ಟ್. ಡಬ್ಲಿ
ಇಟ್ ಈಸ್ ಅ ಡಬ್ಲಿ ಲಿಂಕ್ ಲಿಸ್ಟ್. ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಟೈಪ್ ಡಿಫೈನ್ಡ್ ಸ್ಟ್ರಕ್ಚರು ಐತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅಡ್ವಾನ್ಸ್ಡ್ ನೋಡ್ ಸ್ಟ್ರಕ್ಚರ್. ಜೆನರಿಕ್ ಡೇಟಾ ಪಾಯಿಂಟರ್, ಡೇಟಾನೇ ಪಾಯಿಂಟ್ ಮಾಡ್ತಿದೆ. ಮೆಮೊರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್. ನಾವು ಬಿಕಾಸ್ ವಿ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಯೂಸ್ ಮೆಲಾಕ್ ಯೂಸ್ ಮಾಡಲ್ಲ ಈ ಫಂಕ್ಷನಲ್ಲಿ, ಈ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ.
ಓಕೆ.
Assigning our memory by ourselves. Meloc ಅಲ್ಲಿ there are some drawbacks which we try to learn there. Even I don't know what are the drawbacks. ನಿಮ್ಮ ಜೊತೆನೇ ಕಲಿತೀನಿ ನಾನು, ನೋಡೋಣ ಏನಾಗುತ್ತೆ ಅಂತ. ಸೊ ದಿಸ್ ಈಸ್ ಅವರ್ ಪ್ರೋಗ್ರಾಮ್. ಈ ಆ್ಯಕ್ಚುಲಿ ಇದು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಆಫ್ ದ ಪ್ರೋಗ್ರಾಮ್. ಆರ್ ಪ್ರೋಗ್ರಾಮ್ ಇಸ್ ವೇರ್, ಆ ಪ್ರೋಗ್ರಾಮ್ ಇಸ್ ಹಿಯರ್ ಲಿಂಕ್ ಲಿಸ್ಟಲ್ಲಿ. ದಿಸ್ ಫಸ್ಟ್ ಪ್ರೋಗ್ರಾಮ್, ದಿಸ್ ಅಡ್ವಾನ್ಸ್ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಪ್ರೋಗ್ರಾಮ್ ಇನ್ ಸಿ ಅಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ 1. ಇದು ನಮ್ಮ ಆ್ಯಕ್ಚುಯಲ್ ಪ್ರೋಗ್ರಾಮ್. ದಿಸ್ ಇಸ್ ದ ಪ್ರೋಗ್ರಾಮ್ ವಿಚ್ ಈಸ್ ಅಬೌಟ್ 4 pages ಲಾಂಗ್.
ಮಂಡೇ ಮಾಡೋಣ.
ಮಂಡೇ, ಬಿಕಾಸ್ ಐಲ್ ಗೆಟ್ ಸಮ್ ಟೈಮ್. ಇವತ್ತು ಮತ್ತು ನಾಳೆ ಐಲ್ ಗೆಟ್ ಟು ಅನಲೈಸ್ ದಿಸ್ ಪ್ರೋಗ್ರಾಮ್ ಒಂದು ಸ್ವಲ್ಪ. ದೇರ್ ಫಾರ್ ಮಂಡೇ 2 hours ಕಂಪ್ಲೀಟ್ಲಿ ಇದನ್ನೇ ಮಾಡಿಬಿಡೋಣ. Now that you have idea of linked list, therefore understanding this program will be a little easy, I guess. ಏನಂತೀರಾ?
ಹೌದು,
ಇವತ್ತಿಂದು ಲಿಂಕ್ ಲಿಸ್ಟ್ ಅರ್ಥ ಆಯ್ತಲ್ಲ?
ಅರ್ಥ ಆಯ್ತು.
ಕ್ಲಿಯರ್ಲಿ ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಮತ್ಲಬ್ ಫ್ಯೂಚರಲ್ಲಿ ಯಾರಾದರೂ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಕೇಳಿದ್ರೆ ಮತ್ತೆ ಕ್ರೇಜಿಯಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕು ನನಗೆ. ಇಲ್ಲಿಂದ ಕಲ್ತಾ ನೀವು ಅನ್ಬೇಕು. ಗೊತ್ತಾ? ಇದರಲ್ಲಿ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಆಕ್ಚುಲಿ ಇನ್ನೂ ನಾವು ಇದು ಮಾಡಬೇಕು, ಲೈಕ್ ಸ್ಪೇಸ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ, ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ, ಅನಲೈಸಿಂಗ್ ಬಿಟ್ವೀನ್ ಅರೇಸ್ ಅಂಡ್ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಅವೆಲ್ಲ ಮಾಡಬೇಕು. ಬಟ್ ಅವೆಲ್ಲ ಮಾಡಕ್ ಹೋದ್ರೆ ಲೂಸ್ ಲಾಟ್. ಅದು ನೀವೇ ಮಾಡಬೇಕು ಅನಲೈಸ್. ಬಟ್ ಸ್ಪೇಸ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ, ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಒಂದು ಹೊಸ ವಿಡಿಯೋದಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನಾನು. ಈಗ ನೆಕ್ಸ್ಟ್ ಈ ಪ್ರೋಗ್ರಾಮ್ ಆದಮೇಲೆ ಐ ವಿಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಗೋ ಟು ಗಿಟ್ ಆ್ಯಂಡ್ ಗಿಟಪ್ ಹೆಂಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಅದು 2 hours ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ.
ಹೇಳೋಪ್ಪ, ಅದು ಲ್ಯಾಬಲ್ಲಿ ಏನು ಗೊತ್ತಿಲ್ಲ, ಏನಿರಲ್ಲ.
ಅದೇ 2 hours ಮುಗಿಸ್. ಆಕ್ಚುಲಿ ಭಾಳ ಈಸಿ ಐತಲೆ. ಗಿಟ್ ಅಂಡ್ ಗಿಟ್ ಅಪ್ ಇಸ್ ವೆರಿ ಈಸಿ ಆಕ್ಚುಲಿ. ಈಗ ಜಸ್ಟ್ ನಾನು ಏನು ಮಾಡಿದೆ ಗೊತ್ತಾ ಇಲ್ಲಿ ಇಲ್ಲಿ now here what now this my program is already what linked to my GitHub. So these are all the commits which I made. ಇಲ್ಲೇ ನಿಮ್ಮ ಮುಂದೆನೆ ಲಾಸ್ಟಿಗೆ ಒಂದು ಕಮಿಟ್ ಮಾಡಿದೆ. ಐ ಆಡೆಡ್ ದಿಸ್ ಚೇಂಜಸ್ ಇನ್ ಇಟ್.
Yeah.
ಕಂಟಿನ್ಯೂಸ್ಲಿ ಗಿಟಪ್ ಅನ್ನ ನಾನು ಮೇಂಟೈನ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಬಟ್ ಇದಕ್ಕಿಂತ ಒಳ್ಳೆಯದು ಐ ಕುಡ್ ಯೂಸ್ ಗಿಟ್ ಬ್ಯಾಶ್ ಆಲ್ಸೋ. ದಟ್ ಈಸ್ ವಾಟ್ ಹಿಯರ್ ಗಿಟ್ ಬ್ಯಾಶ್. ಗಿಟ್ ಬ್ಯಾಶ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಬೋದು. ದ ಗಿಟ್ ಬ್ಯಾಶ್ ನಾವು ಕಾಲೇಜಲ್ಲಿ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಅದು. ಸೊ ದಿಸ್ ವಾಸ್ ಅಬೌಟ್ ಡಬ್ಲಿ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಅಂಡ್ ಸಿಂಗಲ್ ಲಿಂಕ್ ಲಿಸ್ಟ್. ಮಂಡೇ ಮಂಡೇ ಶಾರ್ಪ್ 5 o'clock. ಇವತ್ತು ಲೇಟ್ ಆಗಿ ಎದ್ದಾಳಕ್ಕೆ 4:30ಗೆ ಅಲಾರಾಮ್ ಇಟ್ಟಿದ್ದೆ. ಬಟ್ ಆಗಿತ್ತು ಸ್ಯಾಟರ್ಡೇ ಇತ್ತಲ್ಲ. ಸೊ ನೆಕ್ಸ್ಟ್ ಮಂಡೇ 5 o'clock ಜಲ್ದಿ ಎದ್ದು 5 o'clock ಇಂದನೇ ಸ್ಟಾರ್ಟ್ ಮಾಡಿಬಿಡೋದು. ಅಟ್ಲೀಸ್ಟ್ 7 o'clock ತನಕ ಐ ಗೆಸ್.
ಸರಿ
Okay.
ಸರಿ.
ಬಾಯ್
ಮಂಡೇ
ಬಾಯ್.
Okay.